we're doing complex numbers that has the square root of negative 1 on it, but forgot it. I've got my banner back here in the back that says I love math.
Negative 1 is selfish.
Yeah. I should have worn a shirt today. I feel sad that I didn't do that. Yeah, I'll wear it tomorrow.
Is it like square root of negative square root?
Yeah, it says square root of negative 1 heart math. Yeah.
Like work it out and figure it out.
Yeah, it's a good one. I love math jokes. They're my favorite. If you find any math jokes, you need to send them to me. You can email them to me or print them out and bring them to me, because I've got a bunch of them on like the corners of that board back there. I like to put them up places in my room. There's a bunch back there. There's the one back there. I don't know if you can see it good. It's a good one. It's a good one. It applies directly. There's this guy and this other guy over here. He's got on glasses. And this guy is saying square root of negative 16. So what's he calling him? 4 eyes. So mean. It says mathematical insults underneath it. So I love good math jokes. If you find any good math jokes, send them to me. I'll print them out and we'll put them on the board as long as they are appropriate. Occasionally I'll find one that's maybe inappropriate. Can't print out on the board. There's not a lot of them, but every once in a while there. Somebody somewhere had one where they came across like calculus pickup lines. Some of those are inappropriate. Anyway, let's continue on. All right, example 1. This is not a new example. This is a square root of 50. This is what we were doing the other day. We would just break this down. 25 times 2. We'll get 5 square root of 2. Okay? So what we're looking at today, part of what we're looking at today, is what happens when you have a negative under the square root. Because we know that the square root of a negative number, this means what number times itself equals negative 1. And as far as whole number answers, is there any number, or even real number, rational number answers, is there any number that we can say that number times itself equals negative 1? There's not, right? So, what happens here, though, is mathematicians were running into this issue. They were getting answers where negatives were under square roots. And they had to come up with a way to deal with the negative under the square root. So, what they decided is they were going to make up an answer for this. What number times itself equals negative 1? They were going to say, we're going to just call it I. Right? So, I equals the square root of negative 1. So, by calling this I, it gives us a way of dealing with negatives under the square root. Now, when it comes to actual application of this, I have been told that there are lots of applications of I's. There's something to do with cell phones and like the way the networks work for cell phones. There are other things that I can't remember off the top of my head right now. The reason I cannot remember them is because they are obviously at a pretty high level of application that you're using this sort of stuff. Like you are the person that is programming something that causes the cell phone networks to work correctly. I'm thinking of this person as a very high level employee, right? This is not somebody that's low level here. So we are not going to be doing actual application problems for this stuff because it is going to be needed at a very high level. So right now we just really need to think about this as a way to deal with the square root of -1. Okay? And we have to be proficient with dealing with this because it may come up at later times. Now, for some of you, you may never take any of those maths where it comes up at a later time. I did take a whole class on imaginary numbers in college. Like the whole course was on complex numbers and the complex number system, and we graphed them and stuff like that. I wish I could remember a little more about it than I do. There are some applications we won't get directly into. And just think of it as a way of us dealing with a negative under the square root. Okay? I don't even like to use that word imaginary numbers that much because students are generally resistant to it, because if they're imaginary, why are we even worried about them? And they generally don't want to learn about them. But think of it as a way of dealing with it whenever negatives show up under the square root. So if we have square root of -32, 32 we could break down, right? 32 would be 16 times 2. So what I'm going to do for this one is I'm going to break it down into 16 times 2, but I'm also going to multiply it by a -1. Alright, so what is the square root of -1? It is I. So the I is going to go on the outside of the square root. What's the square root of 16? 4. We typically put that coefficient in front of the I, although technically behind is okay. And then that 2 has to stay underneath the square root. So we get 4I square root of 2. And basically, what's happening there, anytime you have a negative under the square root, it is ending up on the outside as your I, right? So, if we are supposed to write square root of -98 in simplest radical form, okay, how's that one going to break down? Who can tell me? 49 and 2. So, we'll have -1, 49, and 2. Square root of the negative is going to be our I. Square root of 49 is 7. 2 has to stay underneath the square root. So, basically the same thing we were doing the other day, just need the I there with this. You guys have done these before, right? You have some experience with some complex numbers, I think. Actually, I guess these are just imaginary. Alright, so square root of -125. So, Owen, how would that one break down for us? Good, and then also the -1, right? So, square root of 25 is 5. This 5 has to stay underneath. That negative is our I. Okay, we got this. Any questions? Okay, so one of the things that you are going to see is you're going to have expressions like this with multiple roots, and you're going to have to simplify the expression to a plus bi form. Okay, this a plus b times I, that is our standard form for complex numbers. So complex numbers are numbers that have a rational part, a real part, which is your a, just your whole number there, and have an imaginary part, so a number multiplied by the I. So we're just going to go through and break all these down and see what we can combine. So square root of 64, Bo, what's square root of 64? Just 8, right? No square root at all. Just square root of 64 is 8. Let's see. Bailey, what does square root of negative 48 break down to? So what numbers could we multiply to get that 48, Bailey? Joshua, have you got, well, we could multiply those together to get 16 and 3, right? So if we're doing negative 1, 16, and 3, we would have square root of 16 is 4. The negative is our I. The 3 stays underneath the root. Okay? Amanda, what about square root of 25? It's just 5. And Caleb, what about square root of negative 75? Good. 5I root 3. So then we're just going to combine our like terms. So we would have the 8 and the 5. We can put that together. We'll get 13. And we got 4I root 3 and 5I root 3, which is going to give us 9I root 3. Okay. Questions? All right. This next one has a cube root involved. So it's going to be a little bit different. 3 times square root of 9. What's the square root of 9? 3. So we basically just have 3 times 3, which is going to give us 9. We got the square root of 1, which is 1. What about cube root of negative 27? It is just negative 3. You can, put yourself a little note here, you can take the cube root of a negative. So you should never have an I if you have a cube root, or fifth root, or seventh root, or ninth root, any odd root there. So the reason being because negative 3 times negative 3 times negative 3, that would give you 9 times negative 3, and that would give you negative 27. Whenever you raise something to the third power, you can get a negative number. So this would end up just being 9 plus 1 minus 3, so 10 minus 3 is 7. So watch out for the cube roots. You can take the cube root of negatives. You will not have an I for those. Okay, questions so far? All right, try this one on your own. In fact, try the next 2 on your own. Next 3 on your own. like a variable, but these two right here, you have a plus sign in between. You're doing 3 times 7. You don't have these 3. So you would have like 30. The I is where that negative went, so you keep the sign right there. Yeah, so you keep that sign. Because the negative only comes out as like the I. Alright, check with the neighbor, see if you guys are getting the same answer.
8.
You can use the calculator.
So, the cube root of 125 would be our 8th grade file. And then
8th grade year, I would have said the same thing. That was pre-Desmos.
and then we went remote, so then after that, comes after that being 15.
Yeah. It was,
This was my picture.
yeah. I got one for Christmas. I was in high school
No,
too.
the fact that I was so happy about her.
Yeah.
Yeah.
Yeah. I was like 16 and I was like, Mom, I really, really want the TI-89, please.
I was in Texas semester and they didn't use a calculator. They used a different one.
Really?
You had to there's like a keypad on it and you had to click. So I had to relearn it.
Was it still TI? Was it the Inspires?
It was
Yeah.
something, but it was like a new one.
Yeah.
As soon as they gave that to me, I was like,
Yeah.
what?
Yeah.
Can you do like 3 times 7 on?
Yes, you can multiply the 3 times. What you cannot do is like 3 plus 7. Yeah. Yeah. But they are. I don't encourage kids to buy calculators like I used to because of Desmos. But if you have to take any college math classes, they usually require you to buy them. So hold on to them. You'll use them one day, probably. More than likely, anyway. All right. The quickest way to take a cube root on a calculator is to do this. If you're doing a cube root, I realize it's not applicable on this particular problem. A cube root of 27. The quickest way to do it on the calculator is 27 to the 1/3 power. We use it in calculus. It's not, doesn't have to be calculus. But, so if you make a fractional exponent, that's the quickest way to do it. Because otherwise you got to go through like all these math menus and stuff. It is on there. But, and if it was 4th root, it'd be 1/4. If it was 5th root, it'd be 1/5. Alright, here's the answer to that first one that you guys were doing on your own. You should get -1 plus 13i. Somebody over here, I can't remember who it was somebody was asking me a good question. They were a little bit unsure whether or not this 6 right here needed to be positive or negative. That can be a little bit confusing. The negative under the square root, what does it become? It becomes the I. So it does not change the sign of what is out there. The I is that negative. Now, it's a little different with cube roots. We'll see that. Any questions on this one? Okay, here. All right, here's your next one. Okay, so now to do a cube root on a calculator, you can type in -125 to the 1/3 power into your calculator. It will tell you that it is -5, and you'll be allowed to use your calculator on this. You will not be allowed to use Desmos on a lot of the stuff that we're doing, but you will be able to use the handheld calculator, so you can do that. The other thing, though, is these are typically going to be whole number answers that you're going to get. So the other way to think of it is just what number raised to the third power would give me 125. And you know it's usually going to be pretty small numbers, so you can run through those also, and you would know it's -5. Now, with the cube root, that negative does not become an I, right? That negative is the negative in the -5, right? So then you're doing -3 times -5, which does give you the +15. But this negative right here, it becomes the I, so we don't change that positive sign right there. And so when we combine, we should get 11 plus 5i. Okay, here. All right, and that last one you had to do in this section, you should get 33 plus 21i. So for that one, you got your 6. Cube root of negative 729 was -9. Square root of negative 49 is 7i. And I had several questions about this as well. Can you multiply those together? The answer is yes. You can multiply them. What you cannot do is add a number and I, or subtract a number with an I term. So you're going to combine the 6 and this positive 27 that you get here to get 33. The 3 times 7 gives you 21i here. It's very much like dealing with variables, right? If we had 3 times 7x, we could do that, right? We'd get 21x. But if we were trying to do 3 plus 7x, we could not put those together. I is more or less treated like a variable with some exceptions that we'll see here soon. Okay. All right, we okay here? All right, let's look at multiplying complex numbers. Okay, let me remember. It doesn't matter on this particular problem. So there are some of these that I ended up getting wrong because I was doing these in a different order and it caused there to be a wrong answer. It won't happen on this particular one. But let's write ourselves a note here. I want you to pull out I's first. The reason for that is if you do not, you will get answers that are not imaginary when you should have ones that are imaginary. So when you're multiplying complex numbers here, there's no plus or minus signs here. You just multiply the things on the outside of the square root together and things on the inside of the square root together. But before you do that, I would like for you to take the i's out. Hold on. How does this not? I'm going to have to go to Delta Math to remind myself. Maybe not. It really doesn't make a difference. Let me think. Hold on. Let me flip to the one that made a difference. Still though, does it make a difference? Maybe I'm thinking of a different problem. No, it's these. You're going to pull the i's out first. Okay. So I'm going to pull the I out first. It doesn't make a difference on this problem. But it will on the next problem. Okay. So if I multiply things on the outside, I get 6i. And on the inside, I will get 900. Let's see. 900, we can take the square root of that, right? What's the square root of 900? 30. 30 times 30 would give you 900. So we get 6i times 30. And 30 times 6 will give us 180. So 180. Now, you can do these problems in different ways. You could simplify them first before you multiply them together. It's just really up to you, but I do want you to pull the i's out before you multiply things together. I'm going to show you on the next problem why we have to do that. All right, so on this next problem, okay, the correct way to do this problem is you need to pull the i's out first, okay? So that means you'll have 8i square root of 84 times 5i square root of 7. So if we multiply the stuff on the outside of the square root together, we will get 40. What's I times I? I squared. Okay? On the inside of the square root, let's grab the calculator for that. 84 times 7. 588. Okay. So, anybody remember, what does I squared equal? Not positive 1. Negative 1. Because I is the square root of negative 1, right? If we have square root of negative 1 and we square it, squares and square roots undo each other and we just get negative 1. So really this is 40 times negative 1. And 588, oh my goodness. What goes into it? 49 and 12. All right, if 49 and 12 will work, there's something bigger because 12 will break down. Even though 81 go into it. Let's just do it this way. 49 and 12. That'd be 7 root 12. Right? Especially if we're having a hard time finding that bigger number.
196.
Yeah. 12. 12 breaks down into 4 times 3. So when you got really big numbers, it may just be easier, even though you know 12, you're not supposed to leave because it will break down. Still do it that way, right? So 4 times 3 for 12, so that'd be 7 times 2 root 3, so you'll get 14 root 3. So in this particular case, you're getting numbers that are large enough, like 196 being 14 squared. You probably don't have that memorized. It might actually be better to break this down and then break it down again for that. So 40 times negative 1 times 14 is going to give you negative 560 times the square root of 3. And you will be allowed to use your calculator this because you're going to run into some numbers that are kind of large like this that are going to be hard for us to do without a calculator. Now, let me show you why you must pull the i's out first. Let's say that we don't on this one. So we've got 8 square root of negative 84, 5 square root of negative 7. So if we multiply the outsides first, we'll get 40. And on the inside, we'll do negative 84 times negative 7, which will give us positive 588. All right. Then we would get 40 times 14 root 3 whenever we break down the 588, and we would get a positive 560 root 3. So because you're doing that negative times negative underneath your square root, it gives you a positive which erases that out. When in actuality, you should have i's right here, and I squared equals negative 1. So you lose that negative if you do that. So you want to pull the i's out first for these type of problems. Because if you don't, you will get this, which will not be the correct answer. And homework's going to be on Delta Math, so you're going to type it in, and it's going to say, not correct for that. So it feels like you're doing it right, but because of that negative times negative property, it causes the answer to lose that negative when it shouldn't. So we're going to pull those eyes out first. Okay, so powers of I. We just talked about one of them. First of all, I to the first power. Actually, let's do I to the 0 power. What's I to the 0 power? 1. Anything to the 0 power is 1. I to the first power, of course, just equals I. We just did I squared. What is I squared? Negative 1. Okay? What is I to the third? It is negative I. Because if we think about that, we got I times I times I. So these two i's together, that's I squared. That's negative 1 times I, which is negative I. There. All right? All right, what about if we do I to the fourth? It's going to be 1. What about I to the fifth? It's going to start over, right? It's just going to cycle through. 1, I, negative 1, negative I. 1, I, negative 1, negative I. This is the pattern. If you know the first 4, then you can figure out any of these. Okay? So, like one way to do this, one really, really long way, if we know I to the 32s, we could just keep going with the pattern. I to the 5th is I to the 6th is negative 1, I to the 7th is negative I to the 8th is 1. And I could keep going, all right? I could go all the way up to 32. But what are you noticing here about the ones that actually equal 1? Increments of 4, right? So if your exponent is divisible by 4, what are you going to get? 1. All right, so 32 is divisible by 4. You can think of writing it like this. This is like I to the 4th 8 times, right? But I to the 4th is just 1. And 1 8 times is still just 1. Yes. So like on 21, 21 is not divisible by 4. So we're going to think about what's the next lowest number that is divisible by 4. 20. So let's make it I to the 20th times I to the 1st, right? If we put them back together, it's I to the 21st. What is I to the 20th? It is 1 because it is divisible by 4, right? And then I to the 1st power, of course, is just I. So we would get I for that one. All right, 58. Is it divisible by 4? I don't think so. Nope. So it's like 56, right? So I to the 56, that's divisible by 4. And then you'd have to have 2 extra i's. I squared. So I to the 56, what is it going to be? Not negative 1. Yeah, that final answer is negative 1. You're a step ahead. This is 1. And then I squared, we know that it's negative 1. 1 times negative 1 is negative 1. So if you know these first ones here, really, I guess, really the best ones to know, I guess, are these first 4. I to the 1st, 2nd, 3rd, and 4th. If you know those 4, you can always break the rest of these down into a version of that, right? So you don't have to know these all the way up to 58 and 102 and really, really big numbers. Okay? And your answer should always be I, -1, -I, or 1 for a problem like this. So, that narrows down your guesses, at least, if you're not sure. So, you're going to get some problems like this. I to the 29th times I to the 27th times I to the 30th. When we multiply something raised to a power like we see here, what can we do with those exponents?
You just turn it into I -1 -1.
We could do that, and it should work. Or we can combine these first, right? So if I do 29 plus 27 plus 30, it's going to give me 86. I to the 86th power. Right, and if I do 86 divided by 4, it does not go evenly. It gives me like 21.5. Right, so 21 times 4 is going to be the 84. Right, and then I got 2 extra i's left over right here. So this part is divisible by 4. It's just 1. The I squared is -1. So we should get -1 there.
Is it any even number that isn't divisible by 4, just -1?
Yes. Yeah, that'll be true. Okay, you can also kind of think of it this way, like whenever you divide that exponent, if you divide, like in this case, we got 86 divided by 4. We got 21.5. If you get the 0.5, that's going to be a -1. That's like second power, right? If you get a 0.25, that's like I to the first power. If you get a 0.75, that's going to be the -I. So you can also think of it, shortcut it like that. Okay, adding and subtracting complex numbers. This should be very straightforward for you guys. It's just like you would do if I was a regular variable. Okay, so at the level of math you guys are at, you should be very proficient with this. You would just distribute your negative here. So you get 4 minus 2i minus 4 plus 7i. And then just combine your like terms. In this particular case, the 4 and the -4 cancel each other out. So you get a 0 there. And then -2i and 7i would give you 5i. To do another example of that here, we would just distribute that negative. 7 plus 2i plus 3 plus 3i. And then 7 plus 3 will give us 10. 2i plus 3i would give us 5i. Okay, here. All right. Multiplying complex numbers is very similar to what you do whenever you just multiply two binomials together. Like if we were just multiplying -11 minus 7x times 2 plus 6x, we would begin the problem the same way. This is just going to have one extra step at the end. Okay? So if we're multiplying these together, we have to distribute, right? We got to do -11 times 2, which will give us -22. Then we would do -11 times 6i, which will give us -66i. So first terms, outer terms. Inner terms, -7i times 2 is going to be -14i. And in last terms, we're going to get -42i squared. Okay? Now, here's the one thing that's going to be different about dealing with these problems. What does I squared equal? -1. So we've got -22. If we want to, we can go ahead and put these together. We'll get -80i. And we've got -42 times negative 1, which makes it a plus 42. So if we do negative 22 plus 42, we'll get 20 minus 80i. And you want to write that I part second. I want to say that Delta Math counts it wrong if you type in negative 80i plus 20. I could be wrong about that, but I think it does. Because when we write complex numbers, the standard form to write complex numbers is to write the real number part first and then the imaginary part second. So in general, you always want that I part to be last whenever you're writing a question, writing an answer like this. Okay, so it's just like multiplying together, except for you got to replace that I squared with a negative. There. Negative 1. Okay, here. Okay. Let's see. You guys pretty good with this. You guys did this last year. Do we need to do these last examples? We're okay. I think you guys seem to be doing pretty well with this. This example I just threw in there because it was that pulling the eyes out first thing that I forgot to tell you before. Well, let me show you. Let me show you this one right here. Let's do that very last example that you've got there. You can, in this case, pull the eyes out and multiply 72 times 64. And 72 times 64 is going to give you 4,608. You don't have that one? Okay. Well, just look up here. You can, like, write it on one of the others because I do want to look at this. If you multiply these together, you're getting that 4,608. I think what I did is adding that on was going to add a whole nother page that I was going to have to copy, so I just left it off and was going to let you guys write it down. Now I'm remembering my reasons here. I didn't want to waste all that paper for one tiny little problem. So for this, 4,608 is going to be hard to break down because it's such a big number. So what you can do instead is you can break each one of these down first, right? So you've got 4, that negative 72, you're going to have negative 1. We could do 36 and 2, right? So it's going to be 4 times 6i root 2 here, which is going to give us 24i root 2. So I'm breaking down first on this one. And then over here, 64 is a perfect square, right? So this is just going to be 8i, right? So I get negative 32i here. And this is going to be much easier to multiply together now. I'm going to get 24 times 32 is going to give me 768. So I get negative 768i squared times the square root of 2. What is I squared? Negative 1. So this is negative 768 times negative 1 root 2, which gives me a positive 768 root 2. There. So on some of these, it might be easier to break them down first rather than multiplying them together first. Although it can be done either way. It's just you're going to have to break down 4,608, which is a really big number. Whereas 72 and 64 are easy to break down on their own. Okay. All right, so your assignment is from Delta Math. Same conditions apply here. I want you to do at least 30 minutes of work, but, preferably get all the way to 100. But if you have at least 30 minutes of work, I'll give you the credit for it. Whenever you look at Delta Math also. All right, so this is the homework, your complex numbers homework. I only have you doing 12 problems. I think you should be able to get that done pretty quickly. But if you feel like you need extra practice, do some more problems. It will let you do more than 12, okay? Also, tonight, we're going to have a quiz tomorrow. It is going to be on simplifying radicals, which you guys did over the weekend, and on complex numbers. It is going to be in Delta Math, okay? So it'll be problems from Delta Math. So what I did is I just cloned the quiz. This is optional. It is a practice quiz, right? But it is the type of problems you're going to have on your quiz tomorrow. It won't be the exact same because Delta Math has like an extensive question bank that it pulls from, so it's highly unlikely you'll get the exact same questions, but you'll get the same type of questions tomorrow. So you can also, if you would like, do this optional practice quiz, but that is not required, right? It's only the homework 3-2 that is required here. Okay, any questions? All right, go ahead and get started. You got about 15 minutes. Hopefully you'll be able to do several of these. You might be able to get through that first part if you're fast.